here's what we did. We read the problem. We took notes on what was given in the problem. We came up with a figure so we understand what the situation is here. We identified the fact that it's an optimization problem because we are asked to determine the minimum of something. Basically, we're asked to determine x and h for a minimum surface area. We wrote a formula for the surface area. We involved the given information to get rid of one of the variables. We finally, after all these algebraic simplifications, we found a function only of one variable, which is this function. We differentiated to find critical numbers. No critical numbers from this source, but critical number from that. We determined x, which is a critical number, but there is no guarantee that this critical number means anything. But after we study the sign and of the derivative, seeing that it changes sign at 40 from negative to positive, then we know for sure that this gives the minimum surface area, which turns out to be 4,800 square centimeters. Any questions before we look at the next problem? Any questions?
In this example,
yes.
If you wanted to prove that 40 was the minimum, S of 40 was the minimum, if you were to show that, for instance, S of 49 is negative and then S of 41 is positive, would that suffice instead of the table?
S is not negative and positive. S prime is.
Yes, that's what I mean. Like instead of having the table, if you were to plug in 39 for S prime, and then 41 to just have a numerical.
That's exactly it. But you are making it more complicated in a way. But that's exactly what you're doing, right? That's exactly what I did. I plugged in 0 to get negative, and you're plugging in negative. You're plugging in 39 to get negative, and 41. I plugged in 0 and 1,000, but without performing the calculations.
I gotcha.
So you're doing exactly, yes, it's acceptable, but you still have to present it in a table somehow, or just write it, whatever works for you.
So the table then is preferable.
Yes, if you don't want to present this, just do what you just said, S prime of 39 and 41, and that's fine too. I accept it. It's fine. Absolutely. It's correct. Anything else? I'm publishing one video from before so I can move on to the next one. Okay. Can we continue with another problem? Other questions? Very good question. That's perfect. I used 0 and 1,000 in, and I was lazy to really plug it in. And you're plugging in 39 and 41, which is perfect. It's a very good idea. Are we ready for the next problem?
For sure.
Okay. Okay. So let's take a look at the top and bottom margins of a poster. Problem 33 on 333. The top and bottom margins of a poster are each 6 centimeters, and the side margins are each 4. If the area of printed material on the poster is fixed at 384 square centimeters, find the dimensions of the poster with the smallest area. That's one option. Let me read other options to you. A fence of 8 feet tall runs parallel to a tall building, and so on and so forth. That's another option. Find the point on the curve that is the closest to another point. There are so many different types of problems here. Would you like to continue with the poster problem?
That's fine.
Okay, so let's look at the poster problem and then we choose other types. So this is my 5. Okay, 33, page 333. The top and bottom margins of a poster top and bottom are 6 centimeters each. And the side margins are 4. If the area of printed material on the poster is fixed at 384 squared centimeters, find the dimensions of the poster, these dimensions. With the smallest area. Pretty similar idea so far with the one that we just looked at. So we're given that this is a poster, like a frame around a photograph if you'd like. This is the printed area, which is fixed at 384 centimeters squared. And we're told that the margins are such 6644, and we're asked what should the measurements, length and width, or base and height, for a smallest area of a poster. So after reading the problem, we came up with a figure, we put all the information in there that is given to us, and we're asked to find the area of the poster that is minimum, and for that minimum area to identify the base and height. Okay, so can I have anyone tell me what is this distance? And then I'm going to ask, what is this distance?
Is it x minus 8?
Very good, excellent, thank you. This is indeed x minus 8, and obviously the other one is y minus 12. This is where I have to start from because I have the 384. So then x minus 8 multiplied by y minus 12 is our 384 centimeters squared. At this point, I also know that the area that I'm interested in, to make it the smallest, is x times y. This is the function that I want to minimize. And this is the equation that I came up with after I identified all given quantities, identified the area, etc., etc. Okay, so then I will distribute here, see what happens. X times y, negative 12x minus 8y and plus 96 equals 384. And from here, let's see what we can do to get the function. So you could say, well, solve for x times y. I could. So x times y equals 12x plus 8y. And I moved these two to the other side, and I subtract 96. So 384 minus 96 is it 288? Correct me if I'm wrong. So plus 6, 4 and 1, 17, 18 and 1, yes, okay. So this is our function basically. I'm going to erase that. I want it lower. Okay, so we have the area is 12x plus 8y plus 288. Okay, at this point, I found an expression for the area, but I do have a problem. And what is the problem? The problem is that I have x and y in the function, so I don't know how to differentiate a function yet. Differentiate a function of two variables. So somehow I have to remove x or y from here. So we can remove x or we can remove y. How do we do that? Because we can continue till I find a function of one variable. Any suggestions?
Solve for the area in terms of one of the variables.
But the area is the function. So I need somehow to get rid of this. Or this. It doesn't matter, one or the other.
I guess differentiate in terms of...
I can't differentiate. These are not functions of time. So this is just one function, and I needed to have, like we had before. So here we had a function, and it had two variables. It had, it has x and h. And from the given information, I was able to remove h, writing 32,000 divided by x squared, and I replaced it, and now I have a function of one variable, and this is what I need to continue.
So set the area to 384.
So,
that expression.
but you are correct, but the area that is 384 is x minus 8 times y minus 12, which we already used.
Can you substitute in, so by figuring out, so like
I can solve this, if that's what you meant. I could solve that for y. So I have y minus 12 equals 384 divided by x minus 8. So then y will be 12 plus 384 over x minus 8. If that's what you wanted to, if that's what you had in mind.
it was not, but we can roll with that, so.
So now I know that x times y is all this expression. So I can remove y by solving this equation for y. So y minus 12 is 384 over x minus 8. Y minus 12 is this divided by this. And then I'm adding 12 to both sides.
I understand that.
Now all this expression is indeed a function, it's y, function of x. Once I replace it in here, now the function becomes a of x, which is 12x plus 8 multiplied by 12 and plus 8 times 384 over x minus 8, because I distributed 8 to 12 and 8 to this, and plus 288. Any questions so far? I will calculate these, that's 8 times 12 plus 288, and I got, yes, of course, 384. And 8 times 384, I got 3072. We have a function of one variable. It's x, and now we can differentiate. When I differentiate 12x, I get 12. When I differentiate this, I get 0. When I differentiate this, remember it's negative 3072 times, because it's x minus, let me write it first on the side so you know what I'm trying to do. So I changed 3072 x minus 8 to negative 1. And when I differentiate this, I will bring down negative 1, so it's negative 3072 times x minus 8 squared times the inner function prime, which is 1. So that's why this becomes negative 3072 over x minus 8 squared. So because I prefer, that's just a habit of mine, I don't, if the numerator doesn't have x, I don't need to use the quotient rule. It can get confusing with a 0 at the top and minus and this and that. So I keep the 3072 and I put x minus 8 to negative 1. I bring down the power that multiplies 3072 and I subtract 1 from the power. I subtract 1 from the power, and eventually I have to bring it to the denominator, and times the inner function prime, which is 1. So that's how I get this. Now you can say that this function has two critical numbers. I mean, a prime can be undefined for x equals 8, and a prime can be 0. I don't know what it is. In a moment we'll see. However, the function is not defined at 8, so after I conclude that it's an undefined at x equals 8, then I have to look at the function, but the function is not defined at 8, so that's not possible. So my only chance is that 12 minus 3072 over x minus 8 squared is 0. I will separate, and I get this, and then cross multiply or swap these two. X minus 8 squared, 3072 over 12. And what do I get when I divide? Maybe they are maybe 3072 is divisible by 12. It is 256. That's wonderful. So now I get an x minus 8 squared equals 256, or the square root of x minus 8. I should write plus or minus, but we are talking about the square root of 256, and then add 4 to it. Add 8, of course. Add 8 to it. So 16 plus 8. 24. And this is a measurement unit in inches. And you can say I don't believe your claim, and then you're right, because I didn't finish. And yes, if you want to plug in 23 and 25, that's fine too. Perfect. I'm in agreement with that. This is the function. So if we plug, I prefer to plug in 0 because I'm lazy. So when I plug in 0, this will be 3072 divided by 64. And that's negative 48 plus 12 is definitely negative. Let's say I plug in anything else, like a huge number, let's say 1,000, then 3072. Oh, I don't know, I understand why I'm not showing you this. Divided by, I don't know, I put 1,000 minus 8. We know the answer, but okay, so it's going to be positive because 12 minus this tiny number will be positive. Or you plug in, as I said, as Derek suggested, is fine. It was a perfect suggestion. So this is indeed a minimum. in case we are asked to find the smallest area we can. But so we only determined the width or the base. So the base is 24. I have to determine y, and I have an expression for y. Where is my y? Right here. So I have that y equals 12 plus 384 divided by 24 minus 8. 5, 6, 7. And that's guaranteed to be, so 12 plus 384 and divided by 24 minus 8 is 16. And I got 36 inches. So the 24 by 36 inches will give the smallest area of the poster. And if we multiply these two, of course 24 times 36, we get 864 inches squared. Questions?
To